And good day to you all of. Yes, I hope that everything is okay with you. I hope that this is an interesting lecture. They mainly based on my experience. So this we are working several projects, some big international projects, and I mostly work for for security management issues. So this security, you see this cybersecurity situation awareness. So this is very important because we need to know what is going on in our network, and we need to know what to do. Yes, with this, and we need to know not only the current state of but previous state, and what will be in the future. This is very important. And of course, this is not only local knowledge. Should be broad knowledge. So we should know the main trends, and in our system we need to implement different things that the system work properly. You see this picture. Yes. So this is very important that we operate with big data. Yes, for the knowledge management, this is important. Of course, we are working against the hacker and these malicious guys. And of course, this is intelligent. So this correlated with the topic of our course that we need to maybe give knowledge of the human to the system. Yes, but of course, again, if you remember my previous lecture, this is important that the main man in the system, this is a human, the operator. Yeah, that's on different level. There are different operators, so this for the huge, the system, especially for example, the system of the early warning about the attacks against some country. Yeah, so you could remember this big distributed system of such kind. Okay, and this table of content, a lot of issues, and maybe some of the issues I just repeat from the previous lectures. So this lecture I especially have done that this is the last lecture. This is because they connect all the issues which I had before, and also the issue that Professor Abhinav tell you. Of course, this is a little bit more broad. That, for example, this is not connected to some kind of systems, but it could be implemented for also for autonomous vehicle, for 5 and 6G systems. So this is some common knowledge which could be applied. Okay, so this, the first, maybe I just very high level definitions of the security awareness. So this is because there's the area of the control and management, and there are a lot of theories about how to manage, not connected directly with cybersecurity. I just very quickly give you some understanding of such kind of things. And then I go to the security. So this, of course, for us, very interesting to represent the term of the security awareness. Again, this to present this kind of systems. So this is a set of systems. So this there are different classes of systems which could belong to this security awareness systems. And of course, main technology which are related. And then I will talk about this, what I have done with my team in some of the project. Of course, very maybe high level, of course, but if you will have the questions, I can go to details. And also maybe if you're interested in something, of course, we have a lot of research papers in journals and conferences about this topic, which details every aspect which I consider. But for the lecture, of course, this is more top level. Okay. So these notions of the situation and situation assessment. So this, you see the situation. So we need to know what, so this history, what was going in the system before. We need to know what is now and what aspect is projected to the future. So this is important. So we are consider this issue in development. What is important, of course, we need to know the state of this object which are monitoring. So this is important for us. And the process of situation assessment. So this is an evaluation of the situation. It could be quantitative or qualitative. This is usually this hybrid. And of course, there should be different formulation of the problem. So this, if we consider this from viewpoint of achievability of system common persistent goal, so this, what kind of goal, for example, for the big company, what kind of goal should be reached by the company? So we need to know this. If the goal is achievable, if the goal is irrelevant in this case, maybe some cases changed, some information changed, and company couldn't reach this goal. Or we already achieved this goal. Of course, we could maybe change these formulations somehow. It depends again from the formulation of the common problem. For example, from the viewpoint of the proper operation of the system. So we see, so this, if it is normal or abnormal operation. Yeah. If we see from the viewpoint of security, this is both normal or under attack, or maybe normal or not secure, something like this. So for us, this is of course top level conclusion about the state. But to do this, of course, we need to know the state of the all elements and the process in the system on the low, middle, or other levels. And there are some theory of the group behavior control. Yes. So when, for example, we have a set of agents and they fulfill the task. So for, in this case, situation awareness of the agent, or maybe this more common entity, could be specified by, you see this, minimal information about such kind of situation in history, now, and in the future. So the same definition, but we consider it as maybe some set of different elements. Of course, for us, it is important, for example, especially for the previous connection in the previous lecture, for the autonomous vehicle, of course, the situation for the V2X, it depends from the what kind of connection. Is it okay, this connection? Or can we send this information or not? So this is very important, this bandwidth of this connection. This is example at underwater robot, because we had some work for the underwater robot, and for us this was several robots, and they was the agent, and so they had the connections, and this connection could be interrupted. And so some of the agent, all of them fulfill the common task, but after interruption, maybe some damage or something else, the team couldn't perform the common task. So this is very important. Okay, so this is an element that you represent in the theory, what is a security awareness means. Now we go to this cybersecurity. So of course, this is just repeat. You should know from the previous lecture that what is the reason for security violation. Yes, usually this is errors in security policy. You remember security posture, yes, and if it is not correct, or we didn't consider some maybe important aspect, so this could be the reason for the security violation. Of course, in the system there are a lot of vulnerabilities. Some of them are known, some of them not. This is because usually the system are very complex and a lot of software, hardware, and so on. And that's why, for example, we have such kind of attack as a zero-day attacks, yes, which are based on the non-known vulnerabilities. So very important and correct configurations, so and correct parameters for adjustment of the system. I told you previously, if you remember, for the operating system Linux. So there are a lot of parameters which we need to adjust, and if they are initial and we didn't change them, so this could be the reason. So there is huge quantity of reasons why the malefactors can do the attacks. For the security awareness, it is very important to know this. If you remember Zone C, yes, wisdom man from the China. So this, we need to know yourself, we need to know enemy, and we need to know what? So we need to know the environment condition in which we fulfill the operation. So this is the same for our system. Security status changes because of course, new software can be installed, new vulnerabilities appear, we didn't patch, old vulnerabilities exist in the system, yes. So this all elements which are very important. Policy changed and so on. And malefactor strategy depends also from a lot of factors. All of them we need to get into account when we consider this. Okay. The same picture, remember this, of course, for us is very important existing vulnerabilities in the system. So we need to know this vulnerability, we need to know the maybe possible ways of malefactor in our system. This is important. And I will begin with some attack. So this was attack against maybe this infrastructure in the Beijing Olympic Games. So remember, yes, previous lecture, when I talk, because we work with this, we work with these scenarios, and this is open for us, and we analyze this. So this is the infrastructure. So this, you see this network example. So this maybe this external. So attackers. This is web servers for the Olympic Games, which have been one of the authentication, one web server for sport events specification, and web server accreditation, and security element is CM system, which consider this. And there was, of course, the old software. You see this, but this is important because they have some kind of vulnerabilities. So all attacks which have been implemented use such kind of vulnerabilities. And I will try to consider this kind of attack and maybe do some clue for the security awareness system, what the system should know about this, as some initial point to understand this situation. Yes. So these attackers try to search. This is a common view, some common view on this, and the next slide we will see this sequence of attack actions more detailedly. So these attackers from this host try to investigate the web server accreditation. So he trying different kinds of attack. And if he get the access, so he can have information for the different other servers. So this is important. So let's consider this kind of attack. So attackers try at first try to do vulnerability scanning, no success. Then try to analyze different applications, also try to search this software on vulnerabilities. And he finds that such kind of vulnerabilities exist. I will describe later. After this, he could deploy a remote shell. So this he can send software and use it for the investigation of the network. So he tried to search different vulnerabilities for different software, try to do, so this, he gets some information, but this is not enough to have access to the main information. So he tried another, so he tried to brute force the passport. Again, not success. So after this, he tried to search in other vulnerabilities. He finds some of the vulnerabilities here. And after this, he get access to the web server. So this is a usual actions of the malefactor. So you see this. So this is a kind of attack which belong to the so-called slow type. So he malefactor very slowly try to do one action after another. And of course, he trying to compromise web server and to gain access to the confidential information. So this is a main step. So more in detail what I have said before. So you could see this these main steps. So at the final step, he can download the list of legitimate account from the authentication server and apply the web server. So result access to the web server. So the result of the attack is successful. And this is just example of one of the, there was found several vulnerabilities. This is just one vulnerability which have been defined and which have been used. Yeah, you see this. And tomorrow we will try to have the study about this, how to use vulnerabilities, what kind of step to do. And maybe now after this lecture, I try to tell that tomorrow you should have the notebooks. Yes, this is enough with connection to the internet. Okay, everybody. So we will try to practice and such kind of things, how to do this attack graphs. So this again, this is a good example of attack graphs which have been done during this attack on in the Beijing Olympic Games against the system, and this system was compromised. So for the security awareness, of course, if we working with this system, so in this case you see the CM system, we need to see this situation. We need to see this each action of the malefactor. So this on every step we could maybe stop it, interrupt, or maybe in some times we could give the possibility to the malefactor to continue the operation to know his intentions. Yes, it depends from the maybe this criticality of assets and some other conditions. But anyway, we need to know, and if you remember the previous lecture, operators should see these actions, yes, on the dashboards, which I presented yesterday. Okay, so now about cybersecurity awareness. So several some wise men suggested the definition and some components of the security awareness. So this is a work of the Ansley. So here definition that situation awareness consists of the three main components. So the first is a perception. So we need understand the situation. Maybe this preliminary information. Then comprehension. This is he need to understand the situation. And the third, this is projection. Projection. This is maybe there's to see what it will be in the future. For what kind of step from the side of the malefactor could be done as next steps of the attacks. So this is important. So in the cybersecurity domain, so the cybersecurity awareness defined again as preparation, incorporation, processing and evaluation of data from a given system to understand the system's environment to predict the response accurately the potential cyber threats. So this was a definition in several research papers we see. And this is a very used definition from Barfoot. So this cyber situation awareness. So it includes also the same as a previous. Yes, it includes three main elements: this situation recognition, situation comprehension, and situation projection. Okay. So, do you have some questions about this? It's clear, yeah? So let's consider in more detail this situation. So this, if we consider main aspect of situation awareness.
I have one question.
Okay.
In this slide, there is a procedure you have explained also. So is there any specific procedure to do the cyber attack?
Any specific procedure to do cyber attack? So of course I have considered them in a previous lecture. Yeah. So this there are a lot of classes of attacks. Yes. So there are a lot of possible ways how to do this. Yeah. Just some good examples. So there is vulnerability, and the malefactor can't use it to get access to the system. Yes. For example, if this is a password guessing, so that there are some kind of exploits which can do this very quickly, and we can go to the system. This is a concrete example. I answer to your question. Yeah.
Yes. I mean, there is next question following. Actually, recently I have read an article saying that the attackers enter into the Singapore health-related ministry something.
Health
related.
Okay.
So they entered 2 to 3 months back, and they were silent, and after that they fetched all the data.
Okay.
And they did whatever they want to do. They started blackmailing. So how we'll get to know they have entered? Is there any specific steps at least you people are following to know it in advance? Like while they entered, if they found it in between that 3 months gap, they would have notified, right? So.
Okay, so this is maybe this main questions for the cybersecurity. Yes, how to detect attack and how to react on this. Yes, so there are a lot of ways of attackers, and especially there are a lot of attacks. So we call them as a slow attacks. For example, the malefactor doing some action and then having the Trojan or some software which he or she can use remotely, but it can be used also immediately or after some time. As in your case, it's 3 months after. Yeah, so this maybe this is good for the hidden action, because maybe a security operator will try to monitor this situation. Maybe have seen some event, but didn't monitor all the sequence. I didn't see that such kind of software have been intruded in the system. Yeah, and after several times, so everything is okay in the system, operator is quiet. Yes, after this they can repeat the malicious actions. So in this case, they are trying to collect all the confidential information from the system. So again, I need to continue. Yeah, this because a lot of material in the lecture. But this is a question from the previous lectures. So we can see that several examples from this, these attacks. So, if you missed this lecture, you need to see this lecture and you could see. Okay. Because of course the consideration of this question, this is a main question for cybersecurity. Yeah. Okay. What we need to do. Okay. We continue. So the main aspects of cybersecurity awareness. So again, we need to know this current situation. This is a situation perception. We need to know impact of the attack. impact assessment. So again, for this question, we need to know current situation. So maybe this question was answered negatively. So this operator missed this action, yeah, at first. So be aware about how situation evolve. So situation tracking, we can always should consider. In your cases, again, maybe this after 1 day, after 10 days, or after 3 months, we need to consider how this situation evolves. So we need to see maybe the sequences of action, not from the beginning, but maybe which could be done internally in the system. You understand this? When maybe some software try to collect information, then send them from the border of the network. Yeah, so this is important. Then we need to know the adversary behavior. In this case, we need to know so that it could be done slowly, these attacks, and could be repeated. Can know this why and how the current situation is cursed, so the reason of such kind of situation. So and other questions you could see this, for example, the quality of information, can we trust it, and of course the projection. So this for us is important, what consequences of current situation could be in the future. So this is very important slide. So for the security awareness, there is maybe the main questions which system should fulfill, security awareness system. And how we can do this? So this, of course, in some cases we need to know what happened in the system, but how we could evaluate this. We could have this, maybe the content of the events, but maybe some aggregative of this. This is very good to use so-called security metrics, yes? So they aggregate maybe the state of, or maybe the content of several events. So you see this definition from the, from the NIST. So metrics are tools that are designed to facilitate decision making, to improve performance and accountability through collection, analysis, and reporting. So for us is the keywords, this is accountability. So we need to fulfill this security analysis. And also the very close questions. So security metrics can help answer the following questions. So is there any vulnerability in the system? Is there any ongoing attack in the network, and so on? I will show some examples of such kind of metrics. And of course, we need to use different models for situation awareness. Usually, it would be could be the classical, traditional models, and as our course devoted to ML and AI. Of course, now there's trend to use AI models. So this the system should automatically, of course, it should be pre-trained or using some unsupervised learning. We have seen these examples. Yeah, he needs to understand the situation and maybe to help security operator to show the picture what is going on in the system now, what have been before, and what will be in the future. So, of course, AI helps to do such kind of things. So, for us, using different security metrics and using different models is very important. But the art and the science of this is what kind of model to use. So, for us, of course, it's very important. So, now we go into the cybersecurity analytic systems, which apply such kind of models, metrics, and different algorithms, techniques. Common class of such kind of system can be called as a cybersecurity analytic system. So I will show that the class of such kind of system is very broad. So there are a lot of such kind of systems which belong to this kind of cybersecurity analytic system. And we will consider some of them in detail. So this, for example, what does it mean IDC?
Yes.
IDS, yeah. Who knows? This is very important. This several lectures was. So intrusion detection system. Yeah. What is IPS? For example, Dr. Abhinav explained this on this lecture. Huh?
Intrusion prevention system.
Okay. What is CM?
Security information.
Yeah, this is a main kernel term of this lecture. What is a SOC? Yes, so I will explain the others. So this is very important. So this is a different subclasses of such kind of system as cybersecurity analytics system. And they help to understand current situation, help to remember the previous situation, and help to project for the future state of the system. So this is very important. And of course, we have also big data cybersecurity analytics. But now almost all the system are the big data cybersecurity analytics. This is because they need to work with a huge quantity of data. So they need to join a lot of elements from the technique for the processing of big data. So in my lecture, I will just very quickly to show this. This is not new material, but you need to know this. And of course, we have advanced security analytics. So we have simply security analytics, and we have advanced. So advanced, of course, this is the topic of our lecture. So they based on AI, machine learning. This is UABA. You know this? Maybe, yes. So this is very important because who works against our system? This is a malicious hacker. Usually this is a man. Yes, no. But of course it could be, now it could be implemented as an automatic agent. But anyway, the human has created this agent. Yes. So for us, it is very important to know this behavior of users and to take it into account when we are doing some solution for the cybersecurity. Okay, so this is I repeat this slide. So this slide of Harper's cycle of Gartner. So the main technology in the 2022, yeah, and the main classes of the system. Again, just to see, some of them maybe I not explain it, but there are different cybersecurity mechanisms which are very important. For example, again, this is a system we have not considered it, this penetration testing as a service. This is also very important because we need to find the vulnerabilities in the system. Yeah. So this is a special system which we could say they imitate the actions of malefactors, but this is for good. Yes, not for the bad goals. Okay, and also our complex system now almost all this is a CSMA. Who knows this? What is it? So this is of course this is a system having mesh architecture. Of course, we are talking now mostly for the big systems, and they have a lot of components. So this they are spread around the environment. So they have a lot of policy, and we need to mixture them. So this is a mesh, but we need to orchestrate such kind of system. So now this is one also very important trend in the cybersecurity to do this. And this is a previous year. This we just see some shift for the maturity of this technology. For the, for example, I talked about this, so more major technology now, this security information event management, so what we consider. Also endpoint detection and response, so this is an action for the detection and response on the end devices, yes. Threat intelligence, product and services. Who knows what is a threat intelligence? Threat intelligence.
management to check the behavior of the.
So of course
Sensing the network.
so this if you who was on my lecture for the using AI for the defense and attacks, I had some tables. So we need to get and collect a lot of information about threats which exist in our system and which exist in the world. So this because they could be implemented against our system. So we need to investigate different threats and how they could be applied against our system. So this is a very important class of system.
Splunk and OSSIM were the example of the very same thing, right?
Sorry, could you?
Splunk and OSSIM.
CM?
Splunk yesterday.
Splunk, this is a CM system. Not,
Common threat intelligence.
but now this company also have this product for the threat intelligence. This is other kind of products. Okay, so this is of course not my main goal to consider all the kinds of the system, but this is important to know because to understand the situation in cybersecurity and what kind of technology are now on the trend. So this important. If you consider her or as a specialist in cybersecurity. Okay, what other aspect is important? So we have some kind of hierarchical systems for the, on the low level we have a huge quantity of events and data, but we have some processing elements here, and on the high level we of course have not so much element, but if we consider the complexity of decision making, of course the main complexity is here. This is because we need to make decision on this level. So this is a usual picture for the large-scale and big systems. And this is a usual cycle of operations and procedures which are fulfilled on such kind of system. So at first we get the data, so we collect the data, then we pre-process it, get to the repository, we analyze it. So very important process, this is a correlation process, I will consider it. Then we try to understand the situation, to analyze it. So we need to do this security assessment. We use the tools for security visualization. Okay. Here, here. Sorry, that's not the, some of the screen are smart, so this is not. Okay. Then you remember the previous lecture, yes? You remember the lecture about risk analysis, yes? So this countermeasure selection, and then we should spread our solutions for the all the devices. So this is important. So this is a cycle. This is a continuous cycle for monitoring situation for such kind of system. And CM system, so we could consider here, so this, what kind of task we have: security evaluation, countermeasure generation, visual analytics. So we have a security metrics and selected countermeasure as a result. So we are using different modeling techniques for this, and the main result is what to do in some kind of situation. So if some kind of attack, what we need to do in this case? We can stop immediately, or we can maybe do some smart actions. Maybe we could do not only stopping, but we could spread in some solutions on protecting other devices, maybe to strengthen the rules for firewalls. So this is should be set of measures according to the criticality of actions which have been done from the side of the malefactor. So this is could be very complex set of measures which are fulfilled in response of the attack which we have. And of course, for us, very important such kind of main functions which we have. So we need to save logs. So this is some evidence of the actions. We need to do this event management. So a lot of events we need to process somehow them. We need to do the correlation. I will consider on the next slides this. We need to do the street detection to detect the attack. We need to access the vulnerabilities, and we need to know all our assets which we need to protect and their state. So this all action are fulfilled by such kind of system as a security information event management. This is examples, maybe in some systematic way, what kind of information we use for this. So you see this, there are some external data, internal data, some static content, dynamic content. So this and correlation process are used to maybe to do this data in consonance. So this should be not conflicted data. We should pre-process it and use it for the our next action, for example, for countermeasure detection. Okay, so this I call this about the term correlation. So correlation we have in this place. Maybe we could call all this process as a correlation in large. So in this sense, so this finding cause-effect relationship between the analyzed security events. So this, you see this direction from the action which we have. We doing different, we collect information, we pre-process it. So this normalization, anonymization, filtering. What is anonymization? Who can tell? Anonymization. This is well known, yeah? Anonym, yeah? So we need maybe some data to hidden some detail of this, or maybe this some personal information or something. Yeah? Aggregation we collect together. Analysis we try to understand what is the content of this. So correlation, finding the cause-effect relationship. So the arranging and prioritizing. So for us this is very important to have some priority of different events. So which events need to be processed in the first place. So for example, in this case, some attack we detected. So and this is a very critical attack. So we need to, of course, to understand what kind of attack and what to do in this case. So when I participated in this international project about creation of the security information event management, this was the main problem which we need to solve in this project. So the first is to improve the correlation process between the different events. The next to make this system adaptive, scalable to the different events. Then again, you know this projection, the action of projection. So for us it is important prognosis, prognostic security analysis. So when we analyze the events, we need to know what will be in the future. So what to do in the future. Of course, this should be, this system should have the high availability and resiliency. So this high availability that we could implement it in any time. Resiliency should be resilient. Yes, it should be not contain the errors and should correctly fulfill all the actions. And of course, real-time countermeasure generation. and possibility of building integrated monitoring and response systems. So in this CM system, this is a component of the SOC, Security Operations Center, and this is one of the main systems, again, which fulfill the task of security awareness. This is important. Okay, so next question is what kind of technologies can be used in such kind of system? Just maybe without detail, I very quickly consider it. So the first, of course, now the main trend that we, of course, working with advanced security analytics. What does it mean advanced? Again, this is we using AI, we using some smart things, we using behavior analytics, and of course, this is maybe some external things, but internal or kernel things that we need the first know the business. What is the business of the company which I try to protect? Because if you know what kind of business, what is the main assets, what is the criticality of the data, we could know what is the priority to protect these assets. Yes? So this is important. Previous kind of system, so such kind of functionality was absent. So now this is absolutely necessary. So need to know rules. So this is a special rules which allow very efficiently to fulfill the task. So this usually if you use ML, machine learning, so this system automatically try to find such kind of rules. If this is a human, so the human, this is experience of the security officer which try to find such kind of rules. And of course, know your user behavior. Know your user behavior, this is because, again, I should repeat, the main subject of attack, this is a user, or hacker, or malicious guy, yeah? Or this is maybe a nation-inspired team of the hackers, yeah, and so on. So we need to know, but for the company, of course, this is internal users of the organization. So we need to know what they do. And we need to monitor their activity. This is important. Okay. And the main technologies, of course, this is now this AI, machine learning, ML is included in AI, of course, yes. This is a big data. This is because huge quantity of data we need to process. And I already told this is user behavior analytics. Okay, and if we are talking about big and fast data analytics, so we need to implement a lot of things in this. So this deep machine learning, deep anomaly detection, so this with, of course, the different, now, of course, this is important, maybe in some cases, some case LLM, large language models, yeah. This, for example, in some cases it could be use some of the example ChatGPT, some for for advising in some case what to do. Fast data enrichment, so this we need to enrich our data maybe by generating some synthetic data. What do you know what does it mean gold data mining? Gold data mining, what does it mean? Who is a specialist in ML? So gold data mining, this means the best practice in the using this data mining techniques. So this the best maybe techniques and so on. Fast report generation and others. So this is some very important elements for the big and fast data analytics. So we have a term big data. Just very quickly, so there are different aspects of the big data. Big data, this means large amount data. This means big gain and high processing speed. This means big data heterogeneity, so this different kind of data, different formats. large differences in data reliability. So we could trust some data and not trust another data. So this is very hard to understand what is a real data, what is a fake. So this is very hard for us. So you see this just 1, 2, 3, 4 model for the big data. But there is 9 models of these additional properties of this. I don't go to detail. This presentation could be given to you. Now we should see different technologies for the big data processing models which can be used. This is a theoretical big data. Not all of them are implemented, but some of them implemented in the, some commercial tools. Maybe you know this Spark, Storm, but this is a good examples of the big data. So for example, this main technologies, of course, previously this was MapReduce, but this is technologies which replacing MapReduce. This is again, some of them are presented here. So this Flink, Storm, Hammer, some other. Do you know some of them? They are very good, well used in the world during data big processing. And also Spark ecosystem. So there's a lot of tools for this ecosystem. So there's combination of different tools which could be used for the processing of big data, including also some libraries for machine learning and some others. Who present on the previous my lecture about visual analytics. So this also important part. So we need to give the information to the security officer, security operator in a good way. Yes, so to understandable. This very important. Also user behavior analytics. So this table considers some difference between traditional CM system and CM system which includes UBA, user behavior analytics. But user behavior analytics, this you see this UBA, but it could be UEBA. So UBA, user behavior analytics, UEBA, user and what?
Event.
Entity. User and entity behavior analytics. What does it mean? So we add, beside users, entity, this is all other elements. So we need to know, for example, some of them could be automatic agents, yes, which fulfill this action. Or maybe this can device with some functionality. So we need to know also to know this its behavior. For example, for the IoT, some of the hacker could include some bug in the system or some additional software, and it should maybe behave differently from from what company producer think about this device. Yes, for example, refrigerator, which starting to loudly at night something doing. Yeah, but this is of course joke, but this good example which could be. Okay, so this UBA, you see there's some additional functionality which could be done for this. Okay, quality indicators for security analytics system. So this very important properties which should be taken into account when such kind of systems function. So the first performance, of course, how sufficient the performance. So for example, real-time response required to attack and some others. The other accuracy. So for example, what kind of attack detect, how, what is a high fidelity of this detection of such kind of attack. Scalability, so it could be used for the large-scale system or just for the simple system. Usability, reliability, interoperability, adaptivity. So this a huge quantity of the properties which are very important for the functioning of such kind of system. So usually when we have this commercial tool, of course, we need to evaluate the system and to consider in what condition they could function. So this is very important to fulfillment of such kind of properties. And this is some kind of template for the classical architecture of such kind of system. So which are based on the ML, on AI. Yeah, this. So what kind? Of course, we need to have some component for the big data storage and processing, for the sensors or getting information, for the data collection, data pre-processing, processing using different techniques for machine learning, data processing, and of course visualization. So this component very important here. And this is example of component-based architecture of such kind of system. So with some maybe examples of the tools which are used. For example, for the collection information, who know this? Wireshark, this network-based tool, yeah? This know this. And map. So we need, of course, to get information from the network. So this is very important. Some classical tools, TCP dump, yeah? This. Who have applied this tool? This is usually if you work with the networks, so yes? So this is important. And of course, this is a set for the data analytics connected with ML. So this, again, for the different aspects connected with pre-processing, feature engineering, and some others. And this is examples of tools which can be used. So this is some template for the choosing the such kind of system. For example, if you're developer of the system, you have this template and you could decide. But usually, of course, we have a lot of commercial system. The other way to have this system, maybe some company could create themselves such kind of system. Maybe not all the element of the such kind of system, but some of them which are important. Or maybe they have already some system, but they would like to add some additional components. So this depends from the company, their possibilities, their staff, their money they have. If they have a lot of money, they of course could have a big system and pay a lot of money for the maybe for changing the patches and additional knowledge from the big company. But this is a huge money, could be. Okay, especially for the company which have a lot of departments distributed around the world. So usually these companies they have their own systems. So, their own specialists. Okay. Next, this is a main research background. So this is maybe some basic work, basic models and technique, which could be used in research for such kind of for creation of such kind of system. Okay. So of course this is not a full list of all the models and so, but maybe some basic model, some traditional model. Because if you will see maybe some good journals and to see some good surveys, so you could find maybe the latest tools and models which are used. This is the basics. First ideas, yes, you see. Please remember, intrusion detection system, yeah? So I hope that after this lecture you will know this. What kind of stages of correlation process? So this is a classical work. I know this Christoph Krugel. We were together in some of the conference on risk advanced and intrusion detection. This is #1 conference on intrusion detection. So we meet in Zurich together with him. So he suggested this main process. But now we have some maybe more long list of the different processes which could be done. So this normalization, aggregation, filtering, anonymization, parallelization, correlation. So please remember previous slide. Yes, there was some graphical picture. Then, of course, signature-based methods. This is the main. Usually, we use signature-based. Who knows what is a signature-based? Who can answer? Yes, yeah, I see there's two specialists. Yeah, maybe some of the silent. I don't know. So you react somehow. Yeah? Please.
Like there can be a particular field that identifies a particular set of features. From that particular signature, we can know, okay, these are correlated ones.
Something like correct answer, but not with high fidelity. I told you this. Okay.
There will be certain specific traits which will be correlating to the effects of that particular event.
So this signature, what is it? This is some concrete example of the maybe this activity. Yes, maybe this is a hash which in some condensed way to depict this. So this idea that, for example, signature-based intrusion detection. So we have this pattern of activity, and if this pattern we see in the network, for example, in local, in the traffic, so this is a attack. Yeah. If don't see this, not attack. But maybe this is a new attack, so we don't have this. Yeah, this pattern. Or maybe they changed a little bit, though this is not exactly this pattern. The same attack, but not exactly. And we couldn't compare this. So this, of course, this is why, of course, this is a high fidelity method, this signature, but only for known attacks. But for new, not. So there are a lot another approaches for this. Okay, so for the signature-based method, so rule-based, template-based, graph-based, based on finite state machine, based on similarity, analogy, and others. So self-learning method. So this is for AI, what we use for AI. But signature-based also for AI. But maybe not here. This we use for not machine learning, but for example, fuzzy logic, fuzzy sets. So in this case, if malfactor a little bit change the pattern, so in this case, fuzzy system could see that this is also belong to the category of malfactor. Fuzzy, you know this, fuzzy sets, fuzzy logic for the smart also processing information. And for the self-learning mechanism, of course, the main is now this main approach is deep learning. Yeah. Okay, main formalism for the attack modeling. So we could specify somehow the attacks. So attacks, this is a sequences of actions. So this, who know the colored Petri nets? This usually you should know, I think. No? So this is also some mathematical formalism, how to specify the actions. I don't go to detail this because maybe you invite me, I will have some additional lecture about this. Okay. Then model checking, very interesting, very powerful technique for the security verification. So for using model checking, almost all our satellite was built. So they should very high fidelity controlling techniques to use for this. So they need to see all the states of the some equipment from one state and connection between this state, and to check that all of them are not dangerous. So this is very important. Other expert system, logical approach, attack graphs. Attack graphs we will try to see tomorrow on the tutorial on this very important also technique for the specification of the attacks. Okay, other important research direction. So representing attack scenarios on malfactor, specification of platform, vulnerabilities, vulnerability scoring. So there are a lot of different databases Maybe you know some of them, which formalize different vulnerabilities, attack scores, and configurations, and some scores for the actions for vulnerabilities. So this is very important for the security assessment. Also, for us, it's very important to combine service dependency graph with attack graphs. So what, who knows that service dependency? What does it mean? Attack graphs, it's clear, yeah? It's a sequence of action. But service dependency, what is it? I don't know, because a lot of people now here, and I don't know the level of preparation for you, of you. Yes, but some of them, okay.
Exactly sure though, but I believe how one service is dependent on the other
Yes.
services, and that graph in itself.
Yes, so this for example, this is very important for the countermeasure generation. So for example, if we have attack and we decide to stop it, so for example, we need to, to close some port or to close some service. But this service was very important for other service, for normal functioning of the system. And if we stop it as a countermeasure generation, so we could stop all the activity of the company. You understand this? Yeah? So this, when we are using these actions for the security awareness, which includes action for detection attacks and for the countermeasure generation, of course, for us it's very important to know how this various complex mechanism for the company functioning and what service depends from the other services. For example, I maybe delete some important guy who fulfill the very important job, and who will work for this in the company. This just example, yeah. Okay, and representing zero-day attacks. Of course, we need to play with these attacks. This is because this is an important component in the system. Again, if you don't know zero-day attack, this is attacks which we didn't know. And so this is a new attack for us. We don't know how they are doing, but they do some action which directed against our system. And we could evaluate it, for example, using a result of this action. Not the pattern of the action, but result of this. So this is important for us. And so we need to know how to represent such kind of action in our models for maybe attack detection. So this usually attack detection mechanism, if you just see it as a sum of elements, this is not simple. This is not simple. We use some technique from AL. We try to categorize the current action, but this is should be some complex element which try to understand if it is known attacks, if it is new attacks, it is sequences of attacks. So this how to combine several different components together for intrusion detection. Okay, this is this very quickly, I just see this slide. This is example of different security protocols which are used in security awareness. So this for the content automation, for the threat analysis automation. So you just need to know this. Such kind of work have been done, and there are a lot of approaches for this. Also for event management automation, for incident tracking, so this big list of this process. And they usually combine it in some maybe protocols of the higher level. And about security metrics. So this we could select, so there are different classification of security metrics. If you remember, security metrics are very important for the security awareness, because this is some kind of indicators of the current situation and the state of the system, yeah, could be. So the simple, this first topological metrics. So there's some metrics related to host and the interconnection, some application metrics, for example, number of some kind of applications. You see this list. Some vulnerability metrics, also some quantity of some system which are important for example, number of known vulnerability instances. So having this, these metrics, so-called topological metrics, we could reason about the state of the system, how vulnerable is this system. Is it possible to how to protect this system, for example? Of course, we need to, again, to reduce the quantity of the bad things in the system, but it is not always possible, yes? Remember the lecture number 2 about this risk management. I talked about it. The other malfactor. So these metrics describe the malfactor metrics. So this, you see this attacker skill level, attack attribution metrics, and some. The other, the attack and attack response metrics. So, for example, attack potentiality. So, attack potentiality is what if you have some attack, what is the powerful of this attack? What this attack can do with our system? What kind of harm can do our system? So in the system, we have a set of such kind of metrics, and we could use them as indicators of the state and indicators of the countermeasure which we generate. Some, of course, high-level metrics. This is an integral metric. So very important, attack surface. Attack surface show us the maybe powerfulness of the attacks. What is a set of attack against, what kind of set of attack which can be applied against our system, what is the point in the system which can be used by such kind of attack. Risk level, of course. Then cost-benefit metrics. Usually, of course, we live in the world of compromise, so we need to weight every action which we have. So of course, every measure costs something. So of course, but we don't have money to do this. Yeah. So we need to decide what to choose. So yes, that's very important. Zero-day vulnerability analysis metrics. So also I talked about 0 days. And there are also different countermeasure selection mechanisms. There are a huge quantity of this, but mainly this is a mechanism which, again, consider different measures and the metrics of the application for the system. So what harm could do these metrics? What advantages of these metrics? How they relate to the business of the company? What is the cost of these metrics? For example, some of the action could require to buy some system, for example, to protect system. But a company is very small and could allow this, to buy such kind of tools. That we need to decide what to do with this, in this case. There are some examples of the, I just go quickly, some examples of different tools which implement such kind of techniques. This is some tools from the Cisco. That is an old system, but this is maybe very important because they opened the new trend in the security systems. So they implemented big data analysis. So this you see this Apache Kafka, maybe you know, and Apache Storm. And they are based on the several also ecosystem for the Apache Hive, Elasticstack, and X-based database. So they was one of the first which implemented big data processing for security analysis. This is the architecture of this system. That's why I showed it. So if you see, this is the old versions of this system. But this is one of the first systems which was implemented for this. And of course, previous lecture was about visual analytics, but this is very important for security awareness. Again, because we give the information to operator, and there are different models which can be used for this. So this is some unusual methods. I just left it. So this from the right hand, this is Japanese system, this with hieroglyph, and from the left side below, this is a clock view. So we could see the activity of the system or the application during 24 hours a day. So and the others, this is a three-dimensional scatter plot which can be used, and we could see the traffic and some very interesting events which are in the traffic. They selected by different colors. Again, I repeat, I like this. So this is for user behavior detection. So this is also 24 hours, but each circle, this is for different days. And we could see activity, maybe some structural, for structuring activity of the user for some time. So for example, again, this is between 9 and 10 p.m. we have some activity all the day, some user doing this. So for us it's important, what is this activity? This is usually for the company or against the company. So we could see the characteristic of this event. So for your example, you told this. So this, for example, we see that some application could send information after 3 months. After 3 months, some information sent to outside the company network. Yeah, in this case, so this Trojan after 3 months starting to send this confidential information of this company. Yeah. Okay, and this is good for the depiction of different attacks. So different ways how to depict different attacks in the system. Okay, so now I have about 15 minutes. I just quickly to show what have been done by us. So this is not new research of my team. This is the newest for the last maybe 5 years. This is in the you could find in the research papers, a lot of research paper. They are open. But this was what is interesting. This was a good cooperation project between some international project between several countries. So we try to build the CM system together. So they include some universities and also some commercial company for building CM system. And the main idea for here, so this we were responsible on the main core of the elements, which for security assessment, for the visualization, for graph analysis, for countermeasure generation in this. There was also a team responsible for the collection of information, some other implementation, some other technique for the same processes and some others. So this is the main key elements of this technology. So we using security repository, which include all the information which I described. This is the first. So we have some effective attack tree generation techniques. So we could see the situation and automatically build attack tree, which we see in the system. Then you see this. We have some mechanism for the 0 days vulnerabilities. And interesting this, maybe you know this. What does it mean, anytime algorithm? Do you know this? Anytime algorithms. Anytime. That this is interesting that we have a set of algorithms or specially crafted algorithm which have a solution in every time. So for example, millisecond, we have a solution. After 10, we could improve and have more, maybe fidelity, high fidelity solution, and so on. So we could get more solution, more information, and get more high fidelity solution. So in every time we have some solution. For example, for countermeasure generation, if we have some attack against our system, we could implement some very quickly some measures and then to change them for more powerful. You understand? Yeah. So this also happened, and the others. You see, so this is some features of approach which we implemented. Okay, and we call this our component in this system that was attack modeling security evaluation component. So interesting, it has two modes of functioning. So the first is design time for configuration and exploitation for using. Then we perform security analysis based on generated attack graphs. So what is also interesting feature, we generate attack graph in offline at first. So we have in offline mode this the special component which generate attack graphs before attacks with some maybe prognosing such kind of attack in the state of the network. And then in the usage time, this attack graph a little bit changed. So this maybe to have some changes in the state and the parameters of the attack. So we have not too much time to generate attack graphs. You know this, it is a very complex process to generate attack graphs. And some other elements. So what are the possible results of this approach? So we have stored attack graphs. We have defined weak places in the network. We have security metrics of analyzed network calculated. We have places for possible 0 days vulnerabilities. So this, according to the complexity, we can calculate for what kind of software and devices could be, by malfactor could be implemented some zero attacks. Okay, and some others. This is just example. This is also architecture. So we have from the left side, this is input data. So on the right side, we have this output data, attack graphs, weak places, security impact metrics, selected countermeasures for security awareness, so on. And this is a common approach for security event analysis. This is very simple from the top level. So the idea, we have we have a model of the network. We have sensors. We have a real network. We get information from the sensor. We have maybe adjustment of the model of the network. And we have simulation. So we could, in our model, so this is maybe, you know, the digital twins technology. Yeah, digital twins. So this is a clear digital twin technology. So we have a model of the system, we have a real object, and we could, in digital twin, change the state of the network. So this is a graph, attack graph. This is maybe current action which we survive, which we monitor in the system. And also we have a weights, so this is a priority of these different actions. So this is a digital twin approach for such kind of things to manage the security of the system.
What is the need to do it in digital twin?
Sorry,
What is the need to do it in digital twin? Means why we are doing for digital twins? Like it is a virtual concept, no?
So what is the need? So we need to somehow to react on the attacks. Yeah. So this idea to have the model of the system. So this is a digital twins, which getting the information from the sensors of the network, having the specify real state of the network with all the elements. So we could model this situation. Yeah.
We are trying to test what are new types of attacks can come, like creating.
Not only new, all the attacks. We should see. So this maybe in the beginning of this lecture, I explain what is the main process of the security awareness. Main elements of this is a know to state of the each devices, know the attacks, yes, know the previous state, know the future state. So this twin allows us to do this, okay? And we also have a set of metrics. So I describe, yes, for the, if you remember, formal methods. So we use it, this set of metrics in our system. And this is when we generate countermeasure, we use this not only the attacks, I asked this, but service dependency. So for us, it is very important. If we remove some program, software, so we stop functioning of some. So how it influence on other services in the system. So this combination of the service dependency and attack graphs, and we have this graph, and we could play and see consequences of different actions for countermeasure. And also we use some ontology. So this is important for the different terms and connection between relations between this term for security here. And they are used for the calculation of security metrics. This is different ontology. Do you know what does it mean, ontology? Yeah? This? No? Ontology, this is a main terms of the subject area which we use. For example, network, device, maybe connection, yes, as some assets and so on. And connection describe the interrelationship between these devices. And also we use some distributed system with sensors and different classifiers. So this system was developed maybe 10 years ago. So this, and we use several analyzers. I just quickly go to this because this, and we have used some combination of the classifiers. This is usual for this approach. Okay, and this now this we consider the security evaluation framework which we implemented here. So this is some, of course, this was the prototype. We have done the prototype and then send it to the company. Yeah, of course, they transform it. But for the evaluation of the system, so this prototype was built. There's different interfaces which have been done. This is yesterday's lecture, so they describe the state of each element, software and hardware, which I used. This is for big. This is main view for maybe this graph of the events. This is a network graph, and this is a graph for different events for attack. Some green, this is a normal. The other color, this is maybe some red, this is attack, and the other color, this is some maybe close to attack. We don't know this, but depends. This is different elements, and also, of course, the component of the big data. So this, and we compare also. Maybe we evaluate different process, which so maybe most time for the calculation it was generation of attack graphs. That's why we had two modes: the first offline, the second online. In online we generate all the big attack graph, but in online again we change it according to the current situation. So this graphic shows us different actions for construction and how much time they get here and what kind of resources they get. I don't go to detail, but just know this. Of course, for when we try to build the system, of course, we have done a lot of calculations, a lot of evaluation. If it is could work in the real time, or we call it a near real time. You understand the difference? Yeah, this real time and near real time. So of course this is a near real time. This is not real time, but this is close. So this we have some maybe more time, maybe. So that's why near real. So maybe what time operator could wait before generating countermeasure. Yeah, this, but not immediately, but sometime which acceptable for the. This is of course this is expert knowledge. So we need to ask the expert: is it okay for you or not, and decide. Now, okay. So this okay, I finished in time. So this very quickly. So some conclusions, very important. So this is a last lecture in this course. So some maybe some survey of the different lectures. So I start with a common lecture about cybersecurity. What is it? What are the components? How to do this, what kind of attacks, what kind of assets, what kind of main agents which implement this. Then we consider the risk management issues. So this is important because we couldn't implement all the protection measures. They cost something. And we could prioritize them and choose some of them which we could implement. This is especially important for the different companies. So the small companies which, for example, couldn't implement all the defense measures. And this is very important. And my next lecture was about using AI for cybersecurity. So this, the first, we selected so that AI could be implemented for cybersecurity, for protection. AI could be used for the attacks. It is interesting that the research work for the attacks prevailing considerably for the for the defense. Yeah. Then that AI could be used for the attack against our AI mechanism, and this is a main trend because now there's almost every new systems are based on the AI. So this is a very important what kind of, and Dr. Abhinav described some kind of attacks against AI for different applications. For example, today lecture for the vehicles, and this is very important. And then number 4 direction, this is using AI for deepfakes. This is also very important because this is connected with cybersecurity very much, not only with other aspects. For example, using generative AI and deepfakes, we could attack our system. This is very important. And we considered the different aspects also in next lectures connected with visual analytics also. And this lecture I demonstrated you as to join all this system in one system, in security information management system. And this system was not just getting from some publication. This was my real experience in developing such kind of system. Of course, I couldn't show you all details of the system. This is high-level specification, but you could see how to build a big security system for the maybe the huge cybersecurity system, as for example, the system for early warning for attacks for India. Yeah, this is a really big, the same as for Russia, for example. This is a big system with a lot of sensors, with several segments, with a lot of levels, and then on high level they describe what to do, for example, for internet with for all the state. So all this system should have a lot of mechanism for this. Tomorrow we will have some small practical work connected with building of attack graphs. So this I will tell how to build, what kind of vulnerabilities could be used, how we could combine several actions together, and we could practice with some tool how to do this. Okay, I finish my work. So this, if you have a question, please. Today it is a holiday for me. There's a lot of people.